Okay, so let's talk about the different quantum numbers. So there are going to be 4 quantum numbers that we're going to learn. The first one, the quantum number is the n, and this is called our principal quantum number. Okay, so the n is my principal quantum number, and this is going to, it designates the size of the orbital. Okay, so this designates the size of the orbital. So my principal quantum number, it's my n. It's also going to be my main energy level. So n is my main energy level, and it designates the size of the orbital. And the numbers are going to be 1, 2, 3, 4, 5, 6, 7. It's not 0, and there's no like halves. Okay, so whole numbers, that's it. Next is going to be the L. Okay, so the L is called my angular momentum. Quantum number. So the L is my angular momentum quantum number. And this describes the shape. So it's going to describe the shape of the orbital. And I'm going to go through and talk about all the different shapes in a couple of slides, in a few couple of lectures. Okay? So this is my angular momentum quantum number. And then, so we want to figure out, well, how do I know what it is? So if I don't know which shape it is specifically, then it's a range. And so my range is always going to be n minus 1 all the way down to 0. So n minus 1 all the way down to 0. So if my n was 4, my L would be 3, 2, 1, 0. Now, if I know the exact shape, then I know what the exact L number is. And before, if it's a range, that's just telling me the range of possibilities. It's got to be one of those numbers within that range. So if my L was equal to 0, that's going to be an S orbital. If my L is equal to 1, is a P orbital. If my L is equal to 2, that's a D orbital. And if my L is equal to 3, that's an F orbital. And I'm going to show you what those orbitals look like. They have shapes. So S, P, D, and F. Those are my 4 different orbitals that we're going to look at. Now we can also talk about the shell and the subshell of a orbital. So the shell is equal to the N. My subshell would be notated as the N and the L. So this would be, for example, I could have a 2s. So my N would be an N equals 2, and then my L would be an S orbital, so a 2s. It's not that we take the S, which is 0, and say 2 plus 0. We're not adding it up like mathematically. We're just taking those two values and just writing it together. So you could have a 2s subshell, you could have a 2p subshell, those kind of things. So that's my N quantum number, and that's my L quantum number. So next we want to look at my last two. So my last two quantum numbers are ML and MS. So M sub L is my magnetic quantum number. So this is going to describe, so it describes the orientation of the orbital in space. So you can think about, like, if this were the orbital, is it this way? Is it this way? Is it this way? So what's the orientation of it? And we're going to go into these a lot more in depth in the next couple of slides. But that's what it means by orientation. Okay, so ML describes the orientation of the orbital in space. My ML is going to be a range, negative L through 0 to positive L. So if my L was a 2, my ML would be negative 2 -1, 0, +1, and +2. So it's going to be a range of numbers. Based on whatever the L is, then my ML is this range, -L through 0 to +L. All right, my last quantum number is the MS. This is the electron spin quantum number. So this is the electron spin quantum number. This describes an electron that occupies the orbital. So this is the first one that describes the electron specifically. This describes the orbital the electron is located in. This describes the orbital that the electron is located in. Also describes the orbital the electron is located in. This talks about the electron itself. Okay? So remember, an electron in an orbital can only have 2 electrons. So this electron can either be alone or paired. And so for my MS, it's either 1/2 or -1/2 or +1/2. Those are the only options. Okay? -1/2 or +1/2. The half is because 2 electrons can be in an orbital. So each electron takes up half the orbital. So that's where we get the half. The positive and negative is that the electron in the orbital could be spinning up or spinning down. So that's why we get a positive and a -1/2. Because one's going to be spinning up, one's going to be spinning down. All right, so those are my 4 quantum numbers. On the next lecture, we're going to talk about, well, do I know what those quantum numbers are? How do I figure them out? And some of them, we can figure them out by just looking at the periodic table and looking at which element we're talking about on the periodic table.